take a look at a process called dimensional analysis. We'll start off with some simpler ones and we'll work into some rather complicated problems. So if it seems like we're making it too much work at first, trust me, by the time we get to the more complicated problems, you'll see the advantage of this method. So to start off, let's look at some simple conversions that we're probably all familiar with. We know 60 seconds is the same as 1 minute, 60 minutes is the same as 1 hour, and there are lots and lots of conversions like this. So the idea of a unit fraction, since 60 seconds does equal 1 minute, 60 seconds divided by 1 minute is going to equal 1 because these are equal to each other, just like 3 divided by 3 is 1. They're equivalent. The numbers, of course, 60 and 1 are not equivalent, but with the units attached, 60 seconds is equivalent to 1 minute, and that equals 1. 1 minute over 60 seconds is also equal to 1, again, because we've got an equivalent amount divided by an equivalent amount. We call these unit fractions unit because they're equal to 1. We can write all sorts of different unit fractions. Now, one thing to remember about algebra is we can always multiply by 1 without changing the value of a quantity. So we're going to take 250 yards, and what we want to do is convert it to feet. So 250 yards. Didn't have my pen ready. There we go. 250 yards. I'm going to write this so that it looks like a fraction over 1. It's equivalent to 250 yards because 250 divided by 1 is just 250. And the unit fraction I'm going to use is that 3 feet is the same as 1 yard. Since they're equal to each other, we're just multiplying by 1. And then what's going to happen is our yards cancel out. 250 times 3 is 750. And we've done a conversion. 250 yards is an equivalent measurement to 750 feet. Let's do one more of these simple ones. 5,280 feet. And this time we're going to convert to yards. Now we know that 3 feet is equivalent to 1 yard. And the feet units cancel out, leaving us with 5,280 yards over 3, which is equal to 1,760 yards. So 5,280 feet is equivalent to 1,760 yards. So when I did these two conversions, I used two different unit fractions. I used 3 feet over 1 yard and 1 yard over 3 feet. So it's important to be thinking about how we decide, do we multiply by 3, do we divide by 3? And so we look at the units we have and the units we want to have. So this first problem, the units I was given to start with were yards, and I knew I wanted to get feet. So I wanted yards to cancel out so that I would end up with feet for my final result. For the second problem, I had feet in my original measurement, and I wanted to end up with yards. So when I set up my unit fraction here, I use 3 feet in the denominator to remove the feet to get them to cancel out and end up with the units of yards. Let's do a couple more of these. If we want to convert 8 kilometers to feet, I'm going to start with 8 kilometers. I'm going to write this over 1. That just helps me line things up. And then I'll look at a conversion sheet. On my conversion sheet, I see that 1 mile is the same as, write that a little more nicely there. Okay, 1 mile. By the way, MI is mile. Just a plain M is meters. 1.609 kilometers. So to set up my unit fraction, I'm going to remove kilometers, and this conversion will get me to miles, but actually I don't want miles, do I? I want feet. So I need a second conversion, And I look around my conversion sheet some more, and I see that 5,280 feet is equal to 1 mile. So I'm going to do a couple of different conversions here. Again, think about the units I want to get rid of. I want to get rid of kilometers, so I'll put my kilometer on the bottom of my unit fraction. And then that's equivalent to 1 mile. So I want to make sure that this distance is equivalent to this distance. And don't multiply yet. We're going to set up a second unit fraction on this one. I know that 1 mile is 5,280 feet. So the kilometers will cancel out, and the miles will cancel out. Okay. So if I multiply across my numerators, I get 8 times 5,280. That's 42,240. Across my denominator, 1 times 1.609 times 1. That's 1.609. My units are feet. Then I can do the division, and I get to 26,252.3 feet. Okay, so convert 10 kilometers to centimeters. You might want to pause for a moment and try this problem on your own, and then start playing the video again to see if we end up with the same result. So I'm going to use 1 foot is 12 inches. That will remove my feet. And then for my, well, that's one I think we probably all know, but it's on your conversion sheet. And then also on our conversion sheet is that 1 inch is equal to 2.54 centimeters. Again, I'm thinking about the units and which units I want to cancel out. The units I want to cancel out, I'll have in the bottom of my unit fraction. The units I'm converting into, I want on the top of my unit fraction. And then I want to make sure my coefficients here make these two measurements equivalent, that 12 inches is equal to 1 foot. 2.54 centimeters is approximately 1 inch. Then once we have it set up, that's when we can multiply across the top. Nothing but ones in the bottom. My units cancel out. And I end up with, using my calculator, 304.8 centimeters. Do you get the same result? So just to summarize here a little bit. So write the given measurement that you started with in the form of a fraction. Write it over 1. That helps us line up numerators and denominators, prevent some silly errors. Then you want to find a conversion fact, looking at your conversion sheet, relating the units you have to the new units. Either the units that you want to end up with, or ones that at least get you closer to the units you want. Sometimes you have to do a couple of these. And then we write a unit fraction that will cancel the units of the given measurement. So original units in the bottom, the ones we're trying to cancel out, and the new units in the top of our unit fraction. You may need to change several unit fractions to get the desired result. And then simplify and multiply. Save all the calculations as the very last step. Get all the unit fractions set up first, and then usually by the time you're dividing, it's often necessary to round. Okay, the second part of our dimensional analysis is looking at area and volume. It's the same principle, but we've got to be careful here. We have to convert in each dimension when we're working with area measurements and volume measurements. So just to start off, think about a piece of paper. Standard piece of paper, 8.5 inches by 11 inches. The area of the paper we can find by taking length times width, 8.5 inches times 11 inches. Would give us 93.5, and we have inches times inches. And so we generally abbreviate that to 93.5 inches squared. And this would be an area measurement. Now, if you want to convert from square inches to square centimeters, we have to convert the 8.5 inches, the 8.5 inches into centimeters, and it's also necessary to convert the 11 inches into centimeters. We can do it all in one step, but we've got to keep in mind we've got to take care of both of those conversions. So one way to think about this, I'm going to take the 93.5 inches squared. Inches squared means simply that I've got inches times inches. And then I'm going to put this over 1. And I know from my conversion sheet that 1 inch is, at least approximately, 2.54 centimeters. So the units I'm trying to cancel out I put in the bottom, and the units I want I put in top. But when I look at this, that only cancels out one of the inches, and I had inches squared, inches times inches. So I have to do the conversion a second time. So that I'm converting both the length and the width from inches to centimeters. So I need a second unit fraction. 1 inch is 2.54 centimeters. And that allows me to cancel out the second inches. The units I have are centimeters times centimeters, and that's going to give me my centimeters squared for my final answer. So I can multiply across my numerators here, since I have nothing but ones in the denominator. That gives me 602.2 centimeter, which is 602.2 centimeters times centimeters is centimeters squared. So the same as what we were doing in our first examples, but because area is 2 dimensions, we have to apply our conversion factor twice. Okay, now if we're working with volumes, volume's a 3-dimensional measurement, so we'll need to do the conversion 3 times. And I'll show you a little bit of a shortcut on this one to set this up. And actually, I want to change this problem just slightly. It's a bigger number. Let's make this 2,550 centimeters cubed to feet cubed. So start with writing out our given dimension, centimeters cubed, and again putting it over 1 just helps us line up numerators and denominators, makes it easier to see the path we need to follow. In this one I'm going to do a little bit of shortcut. You can decide if you like the shortcut method or if you prefer to write things out longhand. So I know that 2.54 centimeters is equivalent to 1 inch. Centimeters in the bottom because I know I need to cancel out centimeters. Inches on the top because I didn't have a conversion from centimeters to feet, so I need to take an extra step in there. I'll go centimeters to inches and inches to feet. But it's not straight centimeters, it's centimeters cubed. So my shortcut is just a shortcut on how to write out the fraction. Rather than writing the fraction out 3 times, I'm just going to note that I need to cube both of these measurements. And then I know 12 inches is equivalent to 1 foot. But because I have inches cubed, I'll need to cube this and cube this in order to get all the dimensions to cancel out and end up with cubic feet. So when I multiply this one out, let's come down here. So I've got the original 2,550. On the bottom, I've got 2.54 cubed times 12 cubed. My cubic centimeters are canceling out. My cubic inches are canceling out. But I still have to cube the 2.54 and cube the 12. And then I'm left with feet cubed because the feet did not cancel out. And I can run all this through my calculator, and I came up with 0.09 cubic feet. And just a note here, when the problem has cubed or squared units, given to you, you don't need to cube or square the number, the coefficient. The exponent's only referring to the units. 4 inches squared is 4 inches times inches, not 4 inches times 4 inches. So we did this example here, we do not want to cube the 2,550. The problem is given to us with 2,550 cubic centimeters. Only the centimeters were cubed. But our conversion was 2.54 centimeters, and we didn't want 2.54 centimeters. We wanted how many cubic centimeters. So because we had to cube the conversion factor, here we cube both the units and the coefficient because it didn't come to us with cubed units. All right, third version here of dimensional analysis is looking at rates of change. So rates of change are units per some other units, and we know that per means divide. So if we've got 88 miles per hour, and we want to convert it to feet per second, that 88 miles per hour is 88 miles divided by 1 hour. And our goal here is to convert to feet divided by seconds. So we've got a couple different units to convert. We need to turn the miles into feet, and we need to turn the hours into second. So pick one or the other to start with. I usually start with my numerator, so I can try to convert the miles into feet. So 1 mile is 5,280 feet. That gets rid of my miles and gets me the feet I wanted. But down here I have hours and I want seconds. So the units I have, hour, are in the denominator. So to cancel those out this time, the units I want to get rid of, I'm going to put in the numerator to get them to cancel out. 1 hour is 60 minutes, which is not what I want. I want seconds, so I need a second conversion here. 1 minute is 60 seconds. Okay, and that should get us feet per second, because the hours will cancel with the hours, the minutes will cancel with the minute, leaving us with the seconds we want. Let's see, so I multiply some of this out. The 88 times the 5,280, my calculator tells me it's 464,640. And then the denominator, 60 times 60, that's 3,600. And this is feet per second. And doing the division, I'm getting 129.07 feet per second. So if you're driving along at 88 miles per hour, you're actually traveling at just short of 130 feet every second. Let's do one more. We're going to try to convert 10 gallons per minute to liters per second. So looking at my conversion sheet, I did not find a conversion that took me directly from gallons to liters, but I can go from gallons to quarts and then quarts to liter. So to get the gallons to cancel out, I'll have 1 gallon in the denominator, 4 quarts in the numerator. A quart is very close to a liter, 1.057 quart is 1 liter. And then I want to get from minutes to seconds. Actually, let me make a note over here. I'm trying to get liters per second. I find having a note here of what I'm aiming for to be helpful. So far, I've gotten the gallons to cancel out, the quarts to cancel out. That leaves me with the liters. And to get rid of the minutes, this time I want to put minutes in the top, and I want to end up with seconds. So sometimes I just write the units down there. I want to cancel minutes and end up with seconds, and then think about what numbers, what coefficients are going to make these equal to each other. And I can think, well, 1 minute is equal to 60 seconds. So I've got my unit fraction. This measurement is identical to that measurement. And then that will cancel my minutes, leaving me with seconds. And then grabbing my calculator, I can take 10 times 4 is 40. And 1.057 times 60, 63.42. And then doing the division then, 0.63 liters per second is equivalent to a rate of 10 gallons per minute.